Hey everyone, and welcome. So, you've probably used tools like ChatGPT, right? Ever wonder what's actually going on inside that AI mind? Today, we're going to dive deep into the tech behind them. We're talking about large language models, or LLMs, and you might be surprised to find out it all boils down to a pretty simple game.
I mean, it really does feel like magic sometimes, doesn't it? You type in a question and boom, out comes this super coherent, creative, sometimes even funny answer. So what's really happening in there? How does an AI go from just a few of your words to a whole paragraph? Well, that's exactly what we're going to break down. Think of it like peeling an onion, or maybe, better yet, cracking open that AI black box. We're going to start with the big high-level ideas, then get into the nitty-gritty, what the AI is actually doing, how it even learns in the first place, and then we'll even look at the real code that makes it all happen. So yeah, let's jump in. All right, so layer one, before we get into anything else, we have to understand what kind of thing an LLM even is. This is like the absolute foundation. So, in the world of machine learning, you've basically got two big families of models. You've got your discriminative models. Think of them as the judges or the critics. They're really good at classifying stuff. You show it a painting, and it'll tell you, yep, that's a Van Gogh. But then you've got the generative models. These guys are the artists. They don't just judge, they create. They could actually paint you a new picture that looks like a Van Gogh. And LLMs, they are 100% in the artist camp. And this really shows you what a discriminative model does. It takes something in, like this painting, and spits out a label or score. It's super useful for sorting and classifying, for sure. But it can't actually pick up the brush and paint. It's a critic, right? Not a creator. Okay, so here's the key takeaway. Generative models, the family that LLMs belong to, are all about learning the patterns in a massive pile of data. I mean, they're fed a huge chunk of the internet, and they just soak it all up. The style, the grammar, the way ideas connect. And once they've learned those patterns, they can use that understanding to create brand new, totally original text that feels like it could have come from that same data set. Okay, so they're artists that create text. Cool. But how? How do they actually do it? How do they paint with words? That brings us to layer two. And honestly, the core job of an LLM is way simpler than you might think. This is it. This is the whole game. Underneath all that complex-sounding stuff, an LLM is basically just a super-powered prediction machine. Its one and only job is to guess the very next word or piece of a word in a sentence. That's it. All the amazing things they do, from writing poems to coding, it all just sort of emerges from being insanely good at this one simple task. Let's walk through a super simple example. Say we give the model this phrase, "My favorite color is." Right now, that model has one mission and one mission only. Figure out what comes next. And it's not just a random guess. It's actually calculating probabilities for every single word in its vocabulary. So based on all the text it's ever seen, it might think, okay, there's a 50% chance the next word is green, a 30% chance it's red, maybe 15% for blue, and on for thousands of other words. Then it just picks the most likely one. Let's say green. It adds that to the sentence, and then it does the exact same thing again. Now the sentence is, "My favorite color is green," and its new job is to predict the word that comes after that. It's this one word at a time process that builds everything. Okay, so quick technical note here, but it's important. I keep saying words, but that's not exactly right. The model actually sees tokens. A token can be a whole word, or sometimes just part of a word, or even a piece of punctuation. Each one gets its own unique ID number. So this is what's really going on inside the machine. It's not seeing letters, it's seeing a string of numbers. These are the token IDs. And its only job is to predict the next number. That's the game. All that fancy neural network architecture is just there to get really, really good at predicting the next number in the sequence. Right, so it's a number prediction machine. But how does it get so good at it? How does it learn to make the right predictions? That takes us to layer three. The whole learning thing is basically a giant feedback loop. Here's how it works. First, the model makes its guess for the next token. Then we look at the training data to see what the actual right answer was. And here's the cool part. We measure how surprised the model was. If it predicted the right answer with 99% probability, it wasn't very surprised. But if it only gave the right answer a 1% chance, well, it was very surprised. And that average surprise over thousands of examples, that's a number we call the loss. Now, the fancy technical name for this average surprise is cross-entropy loss. And this little number is the absolute engine of learning. The model's entire goal during its training is to tweak all of its internal settings, billions of them, to get that loss number as low as it can possibly go.
Yeah, this quote sums it up perfectly. The loss is just a way to measure the gap between the model's guess and the actual truth. So the lower the loss, the better the model is at predicting reality, which means it's learned the patterns in the data really, really well. Okay, we've got the big picture, we know the game it's playing, and we know how it learns. So for our last layer, let's get our hands dirty and see how this stuff actually looks in real Python code. Everything starts with a blueprint. And in code, that's what this is. It's a configuration file that basically lays out the model's architecture. You could see things in here like vocab size, that's how many unique tokens it knows, and N layer, which is how many layers deep the network is. This is literally setting the stage for the model we're about to build. Okay, remember that cross-entropy loss we were just talking about? Well, this is it. This is the code that makes it real. This function takes the model's raw guesses, which are called logits, and the right answers, the targets, and it calculates that surprise score. It's turning the math into something the computer can actually do. And this right here, this is the engine room. This is the training loop. It's a relentless cycle. It feeds the model some data, it calls that loss function we just saw to check how badly it messed up, and then it makes tiny adjustments to the model's brain to try and be a little less wrong the next time. And it does this millions, even billions of times. With every single loop, it gets just a tiny bit smarter. So let's recap. We just peeled back the 4 layers of the AI onion. Layer 1, we learned that LLMs are generative models. They're artists, not critics. Layer 2, their one core job is super simple, just next token prediction. Layer 3, they learn by trying to minimize their surprise, which we call cross-entropy loss. And finally, Layer 4, we saw how this all gets put together in real Python code that builds and trains the whole thing. It's pretty wild, right? All of that incredible complexity we see in tools like ChatGPT, it all comes from this simple game of guess the next word. We've seen how these models learn to basically parrot human language. So it leaves you with a pretty big question. Now that we understand how to teach them, what's the most important thing we should be teaching them next? Something to think about. Thanks for joining me.